video is for Math 95, and this is on these word problems that have to do with a rate of work. They're kind of an interesting type problem, and the method for solving these is algebraic, but it's also really mostly a lot of reasoning. So let's take a look at a couple examples. So in problem 2, it says Mr. Ford can paint the fence around his house in 6 hours. So Mr. Ford takes 6 hours to do the job. His daughter takes 12 hours. Okay. So the idea behind these problems is that Mr. Ford is going to get 1/6 of the job done per hour in 1 hour. Okay? His daughter is going to do 1/12 of the job per hour. So that means every hour, and this is what the problem is asking, how many hours will it take if they work together? Well, it should take less time. Okay? I mean, mathematics, of course, doesn't always model with perfect accuracy what's going to happen in the real world. But as I always like to tell people, is it better than nothing? Yes, it is. Okay? It gives us sort of a preview of what we can expect to see. And, I can tell you that the sciences do a lot of mathematical modeling because it's very expensive to run experiments in the real world, and so they prefer to do some experiments, mathematically first to get an idea for what's going to be happening rather than spending all the money to do all of the experiments live. All right, so in this scenario, every hour that they work together, Mr. Ford's getting 1/6 of the job done, and his daughter is getting 1/12 of the job done. So every hour, he completes 1/6, his daughter completes 1/12, and if we add these together, whether you use a calculator or you create common denominators here, 2 12ths and 1/12 make 3 12ths, which is 1/4 of the job. Okay, so we can set up a formal equation that says, well, let's see, if we do 1/4 of the job per hour, we don't know how many hours it's going to take, and the answer we want is to get 1, the whole job done. And so the way to solve this, multiply on both sides by the reciprocal. X is going to be 4 hours. So together, they should get the job done in 4 hours. And our answer is always going to be the reciprocal of whatever piece of the job gets done per hour. Okay? And I'll make that a little bit clearer here, per hour. So it'll take 4 hours to get the whole job done. So that's a basic idea for these problems. Let's look at a few more examples. I think the trickiest part of these really is adding those fractions together. And of course, understanding the idea and representing how much of the job is getting done every hour. All right. Let's see here. Let's look at problem 4. An old machine requires 3 times as many hours to complete a job as the new machine. With both machines are working together, they require 9 hours to complete the job. Okay? So we're going to, this one's a little bit different, but we're going to have our variables in here this time. So, the new machine finishes the job in X hours. The old machine takes 3 times as long, 3X hours. Okay, so that means every hour, the new machine is completing 1/X of the job every hour. And the old machine is completing 1/3X of the job going on here. Both machines working together, it's going to take 9 hours. Okay, so every hour they work together, they're going to complete 1 over x plus 1 over 3x of the job. Now here you can't really use the calculator, but we can make a common denominator by multiplying this one by 3 over 3. And so this will be 4 over 3x. So that's the amount of the job that's done every hour. We know it's going to take them 9 hours to complete the whole job. So there's our 7. Let's see, so 36 over 3x equals 1. Clear out the 3x on both sides. X is 12. So it takes 12 hours for the new machine, and it takes 36 hours for the old machine, and together, working together, they can finish the job in 9 hours. So the problem asked for how long would it take the new machine working by itself. The answer there is 12 hours. All right, let's see here. More. And these work a little bit differently. They throw little wrinkles into these problems once we get the basic idea down here. So let's see, problem 6. Printing press can print an edition of the newspaper in 4 hours. Okay? So the printing press takes 4 hours to do the job. That means 1/4 of the job every hour. Okay? After the press has been at work for 1 hour, well, if it's been at work for 1 hour, we know that 1/4 of the job has gotten done already. Another press starts to print the edition, and together, both presses require 1 more hour to finish the job. Let's see here. Oh, well, so this press works alone for 1 hour, finishes 1/4 of the job, and that means there are 3/4 of the job left to do. Okay, let's see here. Now we know that both presses together are going to work for 1 more hour, and that'll finish up that 3/4 of the job that they needed to do. Okay? So, we know that this one does 1/4 of the job every hour. Okay? What we don't know is how long it takes the other press to do the whole job, or how much. So this is press number 1. Press number 2, we don't know. We'll call it X hours, which means it's going to complete 1 over X of the job every hour. So, for that last hour that they're working together, press number 1 is going to do 1/4 of the job. Press number 2, we don't know, but it's going to do 1 over X of the job. So, this is what we're looking at. This is just 1/4 plus 1 over X equals 3/4. Subtract 1/4 on both sides. 3/4 minus 1/4 is 2/4, which is 1/2. Cross multiply, 2 equals X. So it turns out press number 2 is faster. It's a faster press. It only takes 2 hours to do the job itself, and every hour it gets half the job done. All right. There's problem 6. Let's look at a couple more here. And like I said, notice how these problems take the basic idea and then introduce these wrinkles to it. All right, so number 8, the new machine takes 6 hours to do the job. That means it'll complete 1/6 of the job per hour. Okay? An old machine completes the same job in 16 hours. So the old machine takes 16 hours, which means it completes 1/16 of the job per hour. Okay, now we're going to have 3 new machines, each doing 1/6 of the job per hour, and 4 old machines, each completing 1/16 of the job per hour. And so all those machines working together will complete this much of the job per hour. So this is 3/6, which is a half. Let's erase that so it doesn't look like divided by. This is 4/16, which is 1/4. So it's doing 3/4 of the job every hour. And then we want to know how many hours is it going to take to finish one whole job. And you can divide on both sides by 3/4 or multiply on both sides by 4/3. In the end, it's going to take 4/3 of an hour, which is about an hour and 20 minutes. Okay. All right. Let's see here. Well, let's look at problem 12, and then that'll be it for these. So, problem 12, we've got 4 water spouts. All right. 1 can fill the tank in 1 day. All right. 2 takes 2 days. The third one takes 3 days, and the fourth one takes 4 days. Okay, well, that makes it easy. There we go. But what this is saying is that the first one will complete the whole job in 1 day. This one will complete half the job in 1 day. This one, 1/3 of the job per day. And this one will do 1/4 of the job per day. So if you get them started at the same time, every full day that they work together, they'll be completing this amount right here. All right. Now, again, you can add these on your calculator. I'm going to create common denominators here. So this will be, let's see, 12/12, 6/12, 4/12, and 3/12. So together we get 18, 22, 25 over 12. So you can complete more than 2 jobs every day if you run these things. If you can fill the tank more than twice over if you're running all these things at the same time. But notice that when we set this up times the number of hours, so this is how many tanks can be filled per day, and then we times it by the number of days, and in the end we only want 1 tank filled. And so this answer is actually going to be less than 1, right? If we do 12 over 25, these will cancel out. 12 over 25, you can leave it like that if you'd like. It's 0.48, or just about half a day. If you run all 4 of these water spouts at the same time, it'll fill the tank in just under half a day. Okay, so that's it for these work problems. Like I said, these are kind of interesting. You may or may not ever run into these, but they are very applicable in terms of working, especially with machines. So anyway, if you have any questions on these, please let me know. Thanks.